Okay, so what if I told you that right now there's this traveler from another star system? We're talking kilometers across, just cruising through our solar system. Because that's actually happening. It's called 3I Atlas, and it's only the third interstellar object we've ever spotted passing through our cosmic neighborhood. And people are kind of losing their minds over it. Now, before we dive in, I need to be upfront about something. This is real, like legitimate astronomical discovery real. But it's also spawned this whole mix of careful science and, well, some pretty wild speculation. So we're going to walk through both, what the astronomers have actually found, and then why this one researcher thinks maybe, just maybe, we should be considering some more exotic possibilities. All right, so basics first. Our solar system, right? It's basically this family of objects, all held together by the sun's gravity. But every once in a while, we spot something that's just passing through. No return ticket. We call them interstellar objects. Think of it like, you know when you're driving and you see a car with out-of-state plates? You immediately know, okay, that person's from somewhere else. Same idea here. So back in July 2025, this telescope in Chile, it's part of the Atlas survey, spots something weird. And after they track it for a while, they're like, yep, this is it. This is 3I Atlas, the third interstellar object we've ever confirmed. The first one was Oumuamua. That was back in 2017, caused a huge stir. Then Borisov in 2019. And now this one. The difference is, this time, we're actually ready for it. We've got better telescopes, better tracking. So what do we know? Like, what does the actual science say? Size-wise, the Hubble telescope's been looking at this thing, and they're saying the nucleus is somewhere between 440 and 5.6 kilometers across, probably on the bigger end of that range, which makes it significantly larger than the other two interstellar visitors we've seen. So that's interesting right off the bat. But here's where it gets really clear. What does this thing actually look like? And Hubble's got these gorgeous images, this classic comet shape, this teardrop cocoon of dust just streaming away from the center. And then the James Webb telescope, which is even more powerful, detected what it's made of. Carbon dioxide, water, carbon monoxide, water ice. I mean, that's textbook comet stuff. That's exactly what you'd see when a comet heats up near the sun. Now, there is one thing that's a bit unusual. The ratio of CO2 to water is really high, like 8-to-1. But here's the thing, and this is important. Unusual doesn't automatically mean alien.
What it probably means is this comet formed in a colder part of another star system than where our comet's formed, which is actually really cool because it's like a window into how different other planetary systems can be from ours. Trajectory-wise, it's on what they call a hyperbolic orbit. Basically, it's coming in on a straight line, going to bend around the sun, and then head back out into deep space. It passes fairly close to what we call the ecliptic plane. That's the flat disk where all our planets orbit, and it's going to make its closest approach to the sun on October 29th or 30th, about 130 million miles out, which is just inside where Mars orbits. And look, I want to be really clear about this, because there's been some weird stuff online. This thing is not a threat to Earth, at all. Its closest approach to us is like 170 million miles away. It's not coming anywhere near us. So the scientific consensus, you talk to professors at Northeastern, Caltech, observatories all over the world, and they're all saying the same thing. This is a comet. It's doing all the comet things, outgassing, forming this coma around it, developing a tail. All the data from Hubble, from Webb, from Mars Orbiters, it all points the same direction. Natural comet from another star system. But then you've got this other voice in the conversation. Avi Loeb from Harvard, you might remember him from all the Oumuamua stuff. He's published some papers saying, maybe we should consider whether this could be something else. Now, Loeb's a legit astrophysicist, Like, he's got serious credentials, but he's also kind of known for being willing to go to these exotic explanations that most other scientists think are jumping the gun a bit. His whole thing is that science needs to seriously consider even unlikely possibilities, including, alien technology. So his argument goes like this. This thing is really massive. His team's estimating over 33 billion tons, and the way its path aligns with our ecliptic plane, he's done the math and he's saying that happening by pure chance is like hundreds to one against. So he's like, okay, if you stack all these low probability things together, maybe, and he's very careful about this, maybe we should at least consider whether something could have been designed. He's even created what he calls the Loeb Scale. It goes from 0 to 10. 0 means clearly natural, 10 means clearly technological and threatening. You'd see it maneuvering, sending signals, giving off artificial heat. Where does he think 3i Atlas sits? He's ranked it as a 4. That's his way of saying it's got enough unusual features to pay attention to, but we're not seeing smoking gun evidence of technology.
No maneuvers we can detect, no signals, no heat signatures, no lights, nothing like that. And this is where pretty much every other astronomer is like, hold on, the ecliptic alignment thing. I mean, yeah, hundreds to one sounds impressive when you say it like that, but think about it. We've only found 3 of these things, total. You're going to see some stuff that looks unusual just by random chance. That's literally how statistics works. Somebody wins the lottery every week, And then there's this whole thing about size. We're way better at spotting larger objects because they're brighter. With only 3 examples, we have no idea what's typical. Finding one big one doesn't tell us it's artificial. It might just tell us we're better at finding big ones. But here's the real kicker, and this is what gets me. This thing is behaving exactly like a comet. Like, exactly. It's outgassing, it's creating a coma, the spectrum shows water ice, CO2 ice. So if this were technology, why would you coat your probe in ice that starts outgassing when it gets heated? Why would you make it act perfectly like a natural comet? That seems like a lot of extra work for no reason. There's this principle called Occam's razor, and I think it really applies here. Start with the simplest explanation that fits what you're seeing. A large comet from another star that happens to pass through our ecliptic plane? Sure, it's unusual, but you don't need any new physics. You don't need to assume aliens exist. You don't need to explain why it acts completely natural. The alien probe idea, though, okay, so aliens have to exist. They have to build interstellar probes. Those probes have to be common enough that we spot one in just a few years of looking. This one has to be covered in ice for some reason. It has to outgas like a real comet, and it has to follow a trajectory that looks like pure gravity. That's a lot of assumptions stacked on top of each other. Look, scientists aren't just dismissing the alien thing out of hand. They're just saying, let's exhaust the natural explanations first. And right now, the natural explanation fits really, really well. Oh, and you might have seen some stuff online about forward-facing glow or headlights. That's been making the rounds. But if you actually look at the Hubble images, we show a teardrop dust cloud with material streaming away, classic comet behavior. Those reports about glowing material in front, they appear to be either misinterpretations or image artifacts, not a separate phenomenon. The European Space Agency is going to get a really good look in just a few days, October 3rd, when their Mars Orbiters observe it as it passes near Mars. That should give us much better data about its structure.
I mean, look, I get where Loeb's coming from. He genuinely thinks science has been too careful, too conservative about the whole extraterrestrial intelligence question. He's worried that by the time we have extraordinary evidence, we'll have missed our chance to study something really unusual up close. And that's an interesting philosophical question, How do you balance being skeptical with being open to surprises? But his critics are like, yeah, consider everything, but you've got to weight possibilities by how likely they are in the first place. Natural comets? We know those exist. We know planetary systems kick them out. We know they travel through space. Alien probes? We've never seen one.
Not even once. That changes how much evidence you need. So what's next? More observations, basically. ESA's Mars Orbiters will observe it on October 3rd when it passes close to Mars. Then in November, ESA's JUICE spacecraft near Jupiter will try to get observations. And even later, March 2026, NASA's Juno spacecraft will get its chance. Ground telescopes are tracking how bright it is, what its composition looks like, as it swings through its closest approach to the sun in late October. But here's what really gets me excited about all this. We're entering this golden age for finding these things. There's this new observatory called Vera Rubin that's about to start up, and it's going to scan the sky every single night with insane sensitivity. Instead of finding one interstellar visitor every few years, we might start seeing one every few months, maybe even more. And when you've got a bigger sample size, the statistics actually start to mean something. We'll figure out what's normal for these objects and what's genuinely weird. Imagine having a catalog of 50 of these things, 100. We could study all the different materials from different stellar neighborhoods, maybe even trace some back to where they came from. That's the real value here, whether this turns out to be just a comet or somehow, against really long odds, something else. It's a physical sample from beyond our solar system that we can actually study. We don't have to travel there. It came to us. That weird CO₂-to-water ratio, that's telling us something about where this thing formed. It was colder there than where our comets formed. And that helps us understand how different planetary systems can be, and maybe how common the right conditions for life actually are. Quick myth busting before we wrap up. Myth 1. Scientists are being close-minded about aliens. Not really. They consider it. They just put it at the end of the list, not the beginning. It's about probability and evidence, not being close-minded.
Myth 2, this thing's headed for Earth. Nope. Closest it gets is 170 million miles away. Its whole orbit is public information. Thousands of observations from hundreds of observatories. No conspiracy, no secrets. So where does that leave us? 3I Atlas is a real interstellar comet, probably at least 5 kilometers across, really high in CO2, making a one-time pass through our solar system. And every telescope that looks at it confirms it's acting like a natural comet. More data's coming. And that's science, right? It's not some dramatic overnight revelation. It's patient measurement, careful analysis, people honestly disagreeing about what the evidence means. So I'm genuinely curious what you think. Should scientists take exotic explanations more seriously earlier on? Or is this approach, checking all the normal stuff first, the right way? Is Loeb doing something valuable by asking uncomfortable questions, even if he's probably wrong? Or is he just muddying the waters? These aren't easy questions, and reasonable people can totally disagree. Science isn't just about data, it's about how we interpret it, how much evidence we need to change our minds, how we balance being skeptical with being open to genuine surprises. The universe definitely keeps surprising us, though. Oumuamua surprised us with that weird acceleration. Borisov surprised us by being so normal. Now 3I Atlas, with its size and composition, each one teaches us something about what it's like out there between the stars. Whether this is a pristine chunk from an alien solar system's early days, or somehow, against all odds, something else, it reminds us we're living in this incredible time. We can detect visitors from other stars. We can figure out what they're made of. We can watch them react to our sun. 20 years ago, we'd never found a single object from outside our solar system just passing through. Now we've found 3. Soon it'll be dozens, then hundreds. And each one refines what we know about what's actually out there. The real story isn't about aliens. I mean, that gets the clicks and the headlines. The real story is about how we do science. That tension between being skeptical and being curious. Being genuinely open to surprises while still saying, look, if you're making an extraordinary claim,
you need extraordinary evidence. 3i Atlas is gonna leave forever. Whatever secrets it has, it's taking them with it. But the data stays, the images stay, and future astronomers with better tools and way more examples to compare, they might look back and catch something we totally missed. That's what's beautiful about science. The evidence doesn't disappear. We keep looking, we keep measuring, we keep asking, and every once in a while, the universe actually answers.
Thanks for watching.